And let's go ahead and get started. All right, guys. Well, welcome back. We are closing out chapter 10, with, of course, which the title of it was configuring RSTP and Etherchannel. And so closing it out, and of course today's going to be a short section, and tomorrow I'm going to give you guys a lab day so guys can actually see it, right? And we're going to finish out talking about a little bit of theory of Etherchannel load distribution and how that load balancing, right, that we were talking about actually works, right? And so within each switch, right, and if you look at the diagram on the PowerPoint, right, each switch, right? Once you configure a Etherchannel, right? It's not just now you have more bandwidth or what have you, right? The brains within, right, the switch, it's a little bit more involved, right? So they have a hardware within, right? Hardware within the switch called the ASIC, right? And so what I learned about the ASIC, right, whenever during my time at Cisco, is that the ASIC, there's multiple ASICs within a switch, okay, and it's assigned to different ports, right? The ASIC, along with the CPU, right, within that switch, makes the decision whenever you're configuring, right, um, things that have to do with traffic flow, load distribution, or what have you. The ASIC works directly with the CPU to say, how should I do this? What should I do? Where do you want me to make this forwarding decision? Okay. And so if you look at the switch, right, we have port channel 1 configured, right? Ryan configured Ether channel 1, port channel 1, right? Right. So what is its forwarding logic, right? So by default, right? By default, Ether channel will support load balancing, right? But, right, it doesn't mean that traffic automatically is going to be distributed between links 1 through 4, right? It all depends on your hashing load balancing method that you choose, okay? And they have a few that you can choose. By default, it is source MAC, right? And they have different meanings, and I'll make sure that I send you guys a supporting article for this, right? And it's at the CCNA level, it's simple to understand, right? It's not really a huge key topic to understand for the exam, but they may ask you what the load distribution looks like, right? And so by default, whenever you configure Ether channel and you don't change anything to the hash of load balancing, right? By default, it's going to use the source MAC hash, right? What does that mean? It means Ryan, right, is telling the switch to say, hey, port channel X, Y, and Z, right? Load balance based on the source MAC address, right? And of course, if we use a source MAC address, and this is just an example, right? It'll go ahead and forward traffic out the same physical interface. It will not load balance that traffic with different interfaces. Okay. All right. And I know it's kind of complex right now. And of course, a packet capture would suffice a little bit better, but we'll talk about it more tomorrow whenever you guys see those packet captures, what have you, right? So here are the different hashes, right? Or load distribution methods that you can go ahead and choose, right? We got 3 at layer 2, right? We got 3 at layer 3, right? And we got 3 at layer 4, okay? All right. So, and we'll talk more about it later. I just need you guys to go ahead and just worry about the layer 2 for now, right? Layer 2 source MAC, right? It's source MAC address, right? Destination MAC, of course, destination MAC address, or source destination MAC. It's of course using both the source and destination MAC. And now I want you guys to just focus on layer 2 for now, right? And so back to what I was saying, right? Depending on how you design your layer 2 topology, right? And you design your Ether channel load balancing hashing distribution method, right? If you just go with the default and don't change anything, right? Here's how the source MAC method works, right? Traffic that goes out of, um, you know, interface 1 out of the port channel is just going to strictly go over port 1. It's not going to switch to different ports, right? Source MAC 2, right? A different session, a different host that's maybe connected to the switch that's going out of port 2. Just going to stick with 2, right? It's it's load distribution, right? But that traffic isn't being broken up. It's just more so, oh, we're not, everything's not just flowing over port one. It's just, hey, maybe PC1 is being over over interface one, PC2 is going over interface two, if that makes sense. Okay. All right. So what are the effects, right? What are the effects of, seeing that ether channel load distribution hash being changed or what have you? Well, right, we don't have to be, rocket scientists or what have you. You actually can go ahead and test, right? And this is actually amazing because I haven't seen this command in a while. And it just reminded me, and I just tested in my lab, which I'm kind of excited to do the lab for y'all tomorrow, is that you can actually see how the load balancing algorithm works, right? And so how the ASIC, right, and the CPU chooses where to send that packet is based on the low order bits, right? What do I mean by the low order bits? Low order bits being the last part of a MAC address, not the high level bits or the beginning of a MAC address. Okay. All right. So it'll all make sense tomorrow. I know a lot of the terminology I'm using is foreign or what have you, and it kind of not makes sense, but just follow me here, right? Using that test ether channel load balance command, right? If you guys take the exam and get tested on this, you can actually, of course, use my favorite command, the question mark, and you'll see test, and you actually can test and put in a falsified MAC address and say, hey, what path would this traffic take on my ether channel, right? For this ether channel, here's the MAC address that I wanted to, here's a source and destination. So it's pretty cool. It's pretty cool. All right. And of course, this is a little bit in depth where it's showing you the low order bit differences, right? So if we're looking, right, if we're looking at that MAC address, right, for the first command, right, you see the first command, second command, and third command, right? You see they're all the same, all the way up until the end of the MAC address, right? The second half of that MAC address, right? Or the third octet, right, of that MAC address, to be more technical, right, are identified with being the low order bits, right? And if you can see, right, it's selecting a different interface to go out of part of that ether channel every single time. Okay. We're going to keep it strictly, right, at the CCNA level. I'm not going to go to the CCNP level or the CCIE level, but that's all you guys need to know from a theoretical standpoint. You can go deeper into what this is, like going over what XOR and decision making, but this is what you guys need to know, right? There can be, right, you can have true load balancing where it's actually splitting up the traffic, or you can just have load distribution where it's, sharing the workload, right, of ingress traffic that's coming in, right, and splitting it up between different interfaces to go out to its respective destinations per that source, right, instead of just going through just one interface. Okay. Same thing you guys just saw. Okay. And that's it, right? So that is the end of chapter 10, right? We'll do this lab tomorrow so you guys can see it and we can actually take the packet captures and you'll see the difference and we'll do the test, what have you. All right. Try to keep it short today, but I will upload this and you guys have a great day.
Hey, just for I have